¿Cómo están? Muy buenos días. Gracias por
Hello, good
acompañarnos.
morning. Thank you for being with us today at this time in a new session of the online seminar, Minerals Week. Today we have Christian Dirscherl, Vice President of Mining, Digging, and Transportation, who's going to talk to us about the materials flow in the digital mine and real-time monitoring of the quality of the ore in materials based in transport. Christian.
Hi, Sebastian. Hi, everyone. I'm happy to.
Hola a todos. Es un placer estar con ustedes de Minerals Week para hablar del flujo de materiales en la minería digital, la gestión de la calidad del material y también comentaré acerca de otros temas.
Let's start it.
Perfect. Thanks. Okay, our C mine, or next slide, please. So first slide. So our C mine MRQ system, material and quality management system, is the Siemens system for pit to port digitalization approach, and it works really perfectly for mines, but also on the other hand on power plants, steel plants, any bulk material handling ports, cement factories, fertilizer plants, etc. The MRQ offers material quality and quantity tracking, high-resolution 3D imaging of stockpiles, real-time material inventory, precise material separation, and blending assistance. Autonomous operation, inclusive collision avoidance systems. So the benefit of the whole system is that it improves the equipment and process efficiency by better knowledge of the stockyard process and also with better machine utilization, especially of stacker and reclaimers. Then there's also steady and consistent stockyard operation because the system is not longer anymore depending on operators because it's working autonomously. It is also reducing machine wear because of the gentle operation of the autonomous operation, and also increase the overall personnel and machine safety, which is a more and more important topic. Next slide, please. So the KPIs for our MRQ system, which we also have seen in the last projects we have executed, is like a high availability up to 5%. There also the performance is increased by 7%. And also at the same time, it is lowering the operational costs, especially of autonomous operation, that we also have less people on site. So there is like an increase or is a reduction of 75%. There's also less energy costs because of the high efficiency of the machines with 7%. And what we have seen in the recent projects is also a return of invest is within 12 months. So, but of course, this is all depending on project by project, but this is like on a few examples, which I also want to talk a little bit more in detail in the next few minutes. Next slide, please. So our MRQ system is basically an extension between the MES system and the process automation. It also has interfaces to all areas. And Yun also touched that already on Wednesday about our digitalization approach in the mining industry with the advanced stockyard planning. So we have interfaces from the MRQ system so that we also can show all the data in dashboards. And also we have like all the planning data and also simulation. And the nice thing on our application is it's very modular and also it fits in all operations. And also very important to mention is also that we are independent of the existing automation system or MES system. So we can work also with third-party suppliers, and it's a perfect system for greenfield applications, but also for brownfield extensions. Next slide, please. So the primary package is like our MRQ software, which is also includes also a SQL database. So that is working on servers. So we have also simulation. We have the precise 3D model. We have mathematical models of stockyards. We also have like the data from sensors coming in. And then also we have this real-time material inventory, job management, and also the job simulation. And as mentioned before, that we have the interfaces to the MES system, also to the level 2 automation system. And also we have implementation and interfaces to MineSense that is coming in the end of the presentation, that we also have the opportunity to measure online the ore content and also track that with our system. And very important is the interface from our MRQ system with our autonomous machine operation. So we call it MOM, for manless operation. And so that is basically the automation part of our MRQ system, so that we can run all different kind of machines for the material handling, starting, for example, from ship, train loading, or excavators, then also along the conveyors, stacker, reclaimers, and then also train loading, ship loading, so that all these machines that the measure, they can be running autonomously, and we collect all this data and provide that to the control center. So next slide. So that is one of our first references, which we have done like 12 years ago. This is like the fully autonomous stockyard management for a coal power plant in Germany. So you see on the picture, there's like 4 stacker reclaimers, so that they're running autonomously. It is also very important for this plant that they can run autonomously, because we're blending material so that they have different coal pits. They're getting different coal qualities, and the blending in front of the coal power plant to ensure constant quality for the power plant, to increase the efficiency of the coal power plant. And there's no operator anymore sitting in this kind of machines, that this is all controlled by the control center, and is also ensuring for consistent quality, and also get real-time data of the forecasting and what is stored on the stockyard. And as mentioned, I mean, it is now 12 years in operation. Good. So the next reference is like for our projects in Morocco. That's a project in Africa. So we have received from OCP, that's one of the largest phosphate miners in the world, a contract for 11 MAQ systems for 17 phosphate stockyards. So basically, we're supplying our solution for every stockyard from OCP in Morocco. So that is like an existing stockyard. So that is an extension. So that's, as I mentioned before, we're working here also with third-party automation systems. So because due to the fact that all these mines being executed in different time, and also with different project teams with different operating systems and automation systems. So we have Siemens as one of the suppliers, but also third-party automation systems. So we have this interface and all these machines running autonomously. In addition to also our MRQ system, we also have implemented a condition monitoring system, and also CCTV and communication network to upgrade all the machines, because some of them, they're already in operation since decades. So the next reference is also a very interesting one. This is an example for a steel plant, so that we also handling the coal and iron ore in front of a steel plant. So that it's like for a greenfield stockyard in China. And I mean, as you also can see, we have the references in Germany, in Africa, and also China. It's not really something which is only in Europe or maybe in North America installed, so that we have in all areas globally. And so besides stacker and reclaimers, we also have here the automation systems for circular stockyards, which they're also a little bit different, and the whole stockyard is enclosed. So that because also our system is also working without GPS if necessary, because for environmental reasons, this is becoming more and more important to enclosure the stockyard, and so that also the machines can run. And also for this project, we also have the interfaces, as mentioned before, like to the automation system and also to the MES system. So, and currently, this is in commissioning phase, this project. And it's also very important to mention, because also with digitalization and also like with COVID, the impact we had. So the commissioning is also done by a local team, but also with the specialists from Germany, that they doing everything remotely, because also of the travel restrictions to China. And this is also a good example. And I think it's also a big step in the future, which we have seen in many applications, that also remote commissioning is possible, even also for like big machines and large material handling machines. Okay, so coming now to the next slide, that is showing the cooperation with MindSense. So MindSense is a Canadian company. They're very active with their shovel sense system, so that they have like the possibility with sensors and algorithms to determine the ore quality in shovels, but they also have a system which can be used for conveyor belts. And Siemens and MindSense, we have since 3 years a cooperation, so that we're using the technology, the algorithms from MindSense to implement the quality data in our MRQ system, so that we can also track the material, and we can also visualize that to the mine site, so that basically we measure that on a conveyor belt. We know also the speed of the conveyors, we know and can also simulate the stockpile and stockyards. So to tell the mine exactly when they expect which kind of ore. So the idea is also that then the mine themselves can stabilize the process. For example, also to adapt the grinding or flotation process to increase the recovery. And the future is also what we're seeing is also it even can optimize in future the process, so that there's also possibilities then depending on the stock yard possibilities or stockpile possibilities to blend material. For example, also to have like a consistent hardness of the material, or also to ensure that there's a consistent quality to avoid adapting maybe the flotation process to also increase the recovery. And the idea is really, I mean, if you imagine that a mine would increase the recovery by 1%, what that means like for the environmental impact, for example, reducing of water demand or energy, and also the output of a mine, the profit basically also to have a more ore available. And another idea is also with the optimization of this data, that we also can provide the data to the mine in combination also with shovel sense, so that they also can reconcile the ore body depending on the calculation upfront from the ore body, and also in reality. So, and on the next slide, you can see from MindSense some references that they have done with shovel sense. So this is not anymore just like an idea. This is an existing reference. This is a shovel in Antamina, which is also showing the XRF sensors. The algorithms are in the shovel. And so that MindSense, that they have several projects already running. The majority are in Canada due to the fact that it's a Canadian company, but you also can see that they have also first references in Chile. And there's also, as shown here, one with Antamina in Peru. And the idea is really that we're using the same technology, the same algorithms for our MRQ system in combination with MindSense on the belt sense system, and also providing all this digital data to the mine, and also to optimize the process. Next slide, please. So currently, together with MindSense, we're also working on a reference in Canada. So that is a copper mine. It's not a large copper mine, it's a mid-sized copper mine, probably for South American standards, it's more a smaller site, but the Canadian mid-sized copper mine. So we implementing 2 belt sense sensors. One is after the stockpile, basically feeding the mills. So that is giving and providing exactly the data to the mill to optimize the flotation process and the grinding process. But we also have, or we will also install a belt send system before the huge stockpile. That's basically after the pre-crusher, so that we also have like a 3-kilometer conveying and also the stockpile. The benefit of that additional sensors is also that providing the customer the forecast so that they also know already, in this case, particular case, at least 6 hours of the material, because they know what kind of material that they have in the stockpile. We also have sensors. We will have sensors installed to measure the stockpile, to know how much material is upfront and which quality. And we also have the mathematical models to simulate the stockpile so that we can also tell exactly the mine when they expect the data. Another benefit is also that all the data we measure will be also stored in our database, so that we also have the historical data, can be then also later on aligned and checked with some measurements from the laboratory, can be also checked in a second step with the 3D ore body, and also having, or can also improve then the mining, like from the area, what is waste, what is ore. In combination also in this site, there's also a shovel sense installed from mine sense, so that they also have the data in the first measurement on the shovel sense, then the second in the conveyor, and the third one before the grinding circuit. And I think this is also the future we see. So the combination of simulation, databases, and also sensoring or scanning, and also of course algorithms are very important, because I mean, I mentioned before, the XRF sensors are used here. They basically measure only the surface, but the algorithms that they're also intelligent from mine sense, they're working together with people that they have the knowledge as a geologist, that they can also compare the pictures and scale up to a very certainty of the ore quality to provide this data to the mines. And so that's all from my side. And if you have any more questions, I'm more than happy also to answer that. And I mean, you see also the contact details from my side. So whenever you have any questions, just shoot me an email or give me a call. Thanks a lot.
Thank you very much, Christian. We are glad to have you here in Siemens Minerals Week. Of course, your contact details will be available for all our audience. Thank you very much once again.
Thank you, Sebastian. Thank you, everyone.
Have a good day. Y gracias a ustedes. Recuerden en el sitio mineralsweek.cl.
And thank you. Remember, in the mineralsweek.cl site, we will have Christian's presentation as well as other presentations, so you can contact them if you have any more questions to go deeper into the subject.